Hi students, welcome to Math4U. Today let me explain to you the fundamental theorem of arithmetic. As the name suggests, it is the basic theorem of arithmetic. So what does this theorem say? It says that every composite number can be factorized as a product of primes. So let me explain to you with an example again. So as an example, 6. So how can we factorize this? We can write it as the factors are 2 and 3. So 2 into 3. So both are prime numbers. So this is the product of prime, right? So another one we can write it as 12. What about 12? 12 we can write it as 3 into 4. These are also prime numbers and the product of prime gives you a composite number, right? Yes. So 91, we can write it as 13 into 7, right? So this is the theorem says every composite number can be expressed as a product of prime numbers. Okay, I hope it is clear. And this can be applied in different situations to prove the given number is an irrational number along with some other theorems that we can see in moving forward. Okay, and it helps us to predict the decimal expansion of a rational number would be a terminating or a non-terminating decimal. That actually you have learned in the previous classes about the terminating or non-terminating decimal. What does it mean? Okay, this we can see later. Before going into it, let's see where other situations where can we apply this. So this is a question. Let us do this. Okay, consider the numbers 4 raised to n where n is a natural number. Check whether there is any value of n for which 4 raised to n ends with the digit 0. So we have to check for this 4 raised to n, right? So how can we do this? First of all, let us see how can we write this 4 raised to n as a product. Okay, so factorizing, when we do the factor, we can write it as 2 into 2 the whole raised to n, right? Yes. If it ends with 0, we can say that the number can be divisible by 5. Divisible by 5. By 5. So you can see here 4 raised to n, we can write it as the product of 2 and 2, right? So is there any 5 in this? No. So is it possible to write it like with the digit 0? Is it possible for the value of n with ends with 0? No, right? So we can say that what can we conclude? There is no value of n for which 4 raised to n ends with a digit 0, right? Okay, so let us go to the next question. Let's see how can we do this. Check whether 6 raised to n end with the digit 0 for any natural number. So what is the situation for this also? What will be the product of 6? How can we express it in prime factorization method? 6 raised to n is equal to 6. We can write it as 2 into 3 the whole raised to n, right? So is there any 5 in this again? Is this 6 raised to n divisible by 5? No, no, it's not divisible by 5, right? Yes, it is not divisible by 5. So again, we can conclude that 6 raised to n cannot end with digit 0. Is it clear? For any natural number n? Okay. So I hope today's class is very much clear for you. In the next session, we can see the rest. How can we apply this and where can we do this? Thank you.